Welcome and study with Tanzania Institute of Education.
During electrolysis, either solids or gases are formed at the electrodes. It is interesting to find out the amount of products which will be formed as a result of passing a certain quantity of electricity through an electrolyte. The relationship between the quantity of electricity supplied and the masses or volumes of products formed during electrolysis were studied by Michael Faraday, and he summarized his findings in the so-called Faraday's first law of electrolysis. The aim of this experiment, therefore, is to find out the amount of products which will be formed by passing varying quantities of electricity through an electrolyte. Requirements. In this experiment, you shall require the following apparatus, materials, and equipment: a stopwatch, an electronic balance, crocodile clips connected to wires, an ammeter, a rheostat, two copper electrodes, sandpaper, a piece of cardboard, and a DC source. You also need a beaker, a wash bottle, and tissue paper. Chemicals. Dilute copper sulfate solution, dilute sulfuric acid, and distilled water. Procedure. Take two copper electrodes and clean them thoroughly using sandpaper. Here are the two electrodes already cleaned with sandpaper. Clean them further using distilled water. And after cleaning with distilled water, dry them thoroughly using tissue paper. Label the electrodes as anode and as cathode. Connect the anode to the positive terminal of your battery, where it will be corroded by the electricity we shall be passing through the electrolyte. Set up the circuit as seen on this diagram. Every apparatus will be joined in series. Start with the battery, which is the DC source. Join an ammeter in series. The crocodile clips on the electrodes, and make sure that you fix the right crocodile clip on the right electrode. Otherwise, you will go the other way around. This is the cathode, And you can read on the ammeter that this is the negative terminal. This is the cathode. And you will see it is connected to the negative terminal of the battery. This is the anode. You see that it is connected to the positive terminal of the electrode by following this path. This is the anode. It is connected to the positive terminal of the battery by the following pathway. This is called a variable resistor, but it is also a straight resistor. If you use this terminal and this terminal, this apparatus becomes a straight resistor. But if you use this terminal and this upper one, this apparatus becomes a variable resistor, and the symbol is this box with an arrow. In this experiment, observe the corrosion of the anode as electricity passes through the electrolyte, which means now you have to take the first reading of the mass of the anode. Measuring balance, you can simply put the anode on the balance and take the initial mass. Having taken the initial mass of the anode, you will be now ready to join this anode in the circuit and introduce both electrodes in the electrolyte, which is copper 2 sulfate. When these electrodes are introduced into the electrolyte, you will need to read the time. Use a cardboard paper to hold the electrodes and make sure that they don't touch each other while they are in the electrolyte. Connect the circuit by the crocodile clip. Before introducing the electrodes into the electrolyte, make sure that current is passing through the circuit by doing this, by very fast touching the crocodile clips and looking at, you can see the ammeter that current is passing, and it is passing in the right direction. Start the experiment by introducing the electrodes into the electrolyte and immediately starting the stop clock. Using a stopwatch, stop the experiments after 15 minutes. You can see that the anode is being corroded and the cathode is being deposited by a brick red colored solid. Having done your 4 experiments of measuring the corrosion of the anode, the first 15 minutes you can see 0.07 grams of the anode had been corroded. The second experiment, 0.13 grams of the anode had been corroded. The third experiment, 0.19 grams of the anode had been corroded. And the last experiment, 0.25 grams had been corroded. Each time we had been maintaining a current of 0.21 in all the 4 experiments. And the first experiment took 15 minutes. The second experiment took extra 15 minutes to have 30 minutes. The third experiment, an extra 15 minutes to have 45 minutes. And the fourth experiment took another 15 minutes to reach 60 minutes, which means our experiment has taken a total of 60 minutes at 15 minutes intervals. You can see on this table of analysis that the current throughout the 4 experiments was maintained at 0.21, a constant current throughout. The first experiment took 900 seconds, and if you multiply the current and the time, you get coulombs. And coulombs are the quantity of electricity supplied. In the first experiment, the first 15 minutes, 0.07 grams of the anode were corroded. And you can see up to the 4 experiments how the anode was being corroded and the masses which were being lost. What you will have to do now is to relate the quantity of electricity supplied and with the mass of copper corroded from the anode. Because this relationship is the relationship which Faraday did, because he related the quantity of electricity supplied with the mass of the substance corroded or liberated in the electrodes. Plot the analyzed data on a graph paper. Place the quantity of electricity in coulombs, the independent variable, on the x-axis, and the mass of copper corroded, the dependent variable, on the y-axis. Your graph is a straight line passing through the origin. This is the sketch of the line which passes through the origin. Find the slope of the graph. This slope is the electrochemical equivalent, Z, of copper expressed in grams per coulomb units. And here is a sketch of the graph, I mean how the graph is supposed to look. Here is the slope. You are required to do the accurate plotting using the data available on the table of analysis of results. Looking at the data we have analyzed and the graph you have obtained, find that you are very close to the Faraday first law, which states that the mass of substance liberated or corroded from an electrode during electrolysis is directly proportional to the quantity of electricity passed. This direct proportionality on this graph, that the mass is proportional to the quantity supplied, and you can see the proportionality there. And what is important is the constant of the proportionality is the slope. The slope is the electrochemical equivalent of the element. When the definition of the Faraday's first law is transformed into a formula, it will read M is proportional to Q, which means mass liberated or corroded is proportional to the quantity of electricity passed. And you will find this is shown on the graph you have obtained, so that the slope is the constant of proportionality between M and Q, this constant being the slope and being the electrochemical equivalent, which means the Faraday law now looks M is equal to ITZ, where Q is IT. I means current and T means time in seconds. This is another formula statement of the Faraday first law. If during electrolysis you supply 1 ampere current for 1 second, the mass liberated will be the electrochemical equivalent of the element. Note that differentiate chemical equivalent from electrochemical equivalent of an element.